Hello everyone, welcome back to the Literacy Volunteers of Harrison County YouTube channel. We're a nonprofit United Way agency and we would love for you to subscribe to our channel. Just click on the bell icon below and like our videos and share them with your friends. Today's video is on math and this is lesson number 9 and we're going to be beginning a series of looking at algebra. Okay, so the very first thing we want to know is what is algebra? And it's a branch of mathematics that substitutes letters for numbers. So we're going to be looking at letters. And an algebraic equation represents a scale where what we do to one side of the scale, we also have to do to the other side of the scale. So we're going to look at that. The basics of algebra cover simple operations of mathematics, like addition, subtraction, multiplication, and division. And those involve, we're going to have things that are called constants, which means they never change, right? If something is constant, it doesn't change. And variables, which vary, which means they do change. So we're going to look at things that stay the same and things that change when we look at algebra. Here's an example of an equation. We have x plus 10 equals 0. Here we've substituted the number for a letter, like we said on the first page, and we say this is an equation we can solve for x now. All we have to do is what we do to one side, we have to do to the other side. So here we've added 10, so we have to subtract 10. To get x by itself. We want x alone, okay? So we subtract 10. If we do subtract 10 from this side, we also must subtract 10 from this side. So then we can cancel these out, and we have x by itself, and it's equal to negative 10. The basic math operations performed in the case of algebra, and here we're going to look. We can add x plus y, we can subtract x minus y, we can multiply x times y, or we can divide x divided by y, or we can look at it x divided by y like this. X and y are our variables. Remember we said those are the things that are going to change. The variables, x and y in that instance are our variables. Sorry, those are stuck together. Okay, so here's some examples of basic algebra. We want to find y when y plus 15 equals 30. So I rewrote the equation down here, and like I said, we want to get y all by itself. So in order to get y by itself on this side, we have to subtract 15, so we can cancel out the 15s. What we did to this side of the equation, we also must do to this side of the equation. We bring down y, it's by itself. We minus 15 here, 30 minus 15 equals 15. If you want to check your work, you can always go back and put up, now that we figured out what y was, you can go back up here and put it in for y. So 15 plus 15 equals 30, and that way you know that you're correct. We want to find x when 9x is equal to 63. So here what we've done is we've multiplied. So in order to reverse this, we have to divide. This side we're going to divide by 9 to get x by itself. And this side we're going to divide by 9. 63 divided by 9 is equal to 7. So x is equal to 7. In the last one, if x divided by 7 is equal to 21, then we want to find x. So here we have 1 over 7. Right here. So what we have to do is we have to multiply by 7 over 1 to get rid of this 7. So we multiply by it here. If we did it to this side, we have to do it to this side. So we get x is equal to 147. That's 21 times 7. So let's look at some of these rules of algebra. Every series of mathematics has rules, and so we have to look at the rules of algebra. The first rule is the rule of symmetry. Symmetry means same. When we look at something, it's the same. So if A equals B, then B equals A. That's symmetry. Those are the same. Those are essentially telling you the same thing, right? And so this means the golden rule of algebra goes both ways. That means what we do to one side, we have to do to the other side. So we can write this, we have P plus negative Q is also saying the same thing as P minus Q. Those are the same. Those things are equal, right? Symmetry. We're looking at the same. So that is, in a calculation, we can write or replace P plus negative Q with P minus Q. Now it's symmetrical, just like it was right here. And then we can also replace p minus q with p plus negative q. Those two things are the same. We can move them on either side of the equal sign. All right, the rule of symmetry also means that in any equation we can exchange the sides. So let's put some numbers in and look at the equation. If 15 is equal to 2x plus 7, then we can write 2x plus 7 is equal to 15. Those are the same. Those are symmetrical because we can write them either way. Those two equations are symmetrical. The second rule is called the commutative rule, right? And the order in which we write terms will not affect the sum. When we talk about sums, that's addition, correct? Sum. So if we have a plus b, that is also equal to b plus a. If you had 1 plus 2, it's also equal to 2 plus 1. No matter what order we put these in, it doesn't change the fact that when we add them, we get the same number. So it'll apply to any number of terms. Here we can have a plus b minus c plus d. We can change it to b plus d plus a minus c, or negative c plus a plus d plus b. When we add those, they're all going to be the same when we put numbers in there. It's the commutative rule. That's what they're talking about here. Let's look at an example to p minus q. We're back to p minus q. The commutative rule for addition is stated that for the operation of addition, and then here we have the operation of subtraction. So we can also substitute our addition for subtraction. We can put p minus q, and then we make this q negative, because when we're adding a negative, essentially we're still subtracting from p. So both of those are the same. So p minus q equals p plus negative q. We can take those parentheses off and put negative q plus p. We flip them around, they're still the same. This would give us the same answer. That's where we got the negative c in the beginning. So the commutative rule of multiplication is just a times b is also equal to b times a. 3 times 3 is equal to 3 times 3. 5 times 2 is equal to 2 times 5. We can move them around. The order of the factors, which means the numbers here, does not matter. We can have a times b times c times d. We can have d times b times a times c, same, or c times d times b times a. Those are all going to give us the same answer. That's where we're the commutative rule. One is more, we may associate factors in any way, which means we can group them. We can put parentheses around these and group these factors in any order that we like, but we're still going to get the same sum. So our example is we multiply 2x times 3y times 5z. What we want to do is to multiply the numbers and rewrite the letters. So here we have 2x again times 3y times 5z. Let's pull out the numbers. 2 times 3 times 5, and then put the x, the y, and the z all together. Then we can multiply 2 times 3 is 6, 6 times 5 is 30. We bring our 30 over here and just move over your x, y, and z. Okay, so if we want to practice this, I gave you some practice problems that you could do at home. We would have 3x times 5y, which if we did it this way, we would say 3 times 5 is 15, and then bring your x and y over. And then you could do 7p times 6q, right? It would be the same way. 7 times 6 is 42. Bring your p and q over. Or we can do just like we did up here. 3a times 4b times 5c would be 3 times 4 times 5, abc. So 3 times 4 is 12, and 12 times 5 is 60. So we would put 60 abc. So if you're working at those at home, you can kind of practice to give you to grouping those numbers. The last thing we want to look at is 0. For any number a plus 0 is equal to 0 plus a is equal to a. We're back to a, because if we add 0 to 1, we still have 1, right? We can add 0 to 1 and still have 1. So we're kind of just have a all by itself. 0 is added to any number, doesn't change the number, right? 0 is called the identity of addition because it doesn't change the number. And so the inverse of adding, the inverse of any operation is when we start with 5 and then we add 4, 5 plus 4, inverse means that we do the opposite. So then to undo that, we have to get back to 5. So if we had 5 plus 4 and we want to just get 5 by itself, we have to add negative 4 to this 4 to get 0. That's the same thing we're doing up here. So we have 0, 5 plus 0 is equal to 5 plus 0 is equal to 5. And then if adding negative 4 is the inverse of adding 4, and vice versa, we say that negative 4 is the additive inverse of 4. We're adding a negative to get back to 4. If you had $5 and you went to the store and you bought something for $5, that's negative. Now you're back at 0. You have no dollars. In general, corresponding to every number, there's a unique number, negative a. So we can add a, negative a, and this is that where we flip them. Negative a plus a is equal to 0. So any number combined with the inverse gives us back to the identity, which is 0. 0 is the identity. So if we have 6 plus negative 6, negative 6 plus 6, both of those are 0. They cancel out. We're back to the identity. Here's our last example. If we have x, y, and z plus 0, then we can subtract xyz minus xyz, or the negative, and we're back to 0. So we can just keep getting back to 0. 4, negative 4, now you have 0. 10, negative 10. No matter what number you have, a million, negative a million, you add those together, then we're going to go back to 0. We're back to the beginning. So the next thing we're going to look at in the second part of this lesson is just a little bit of the rules of equations. So if you'd like to join us for that, we would love to have you. Please give us a big thumbs up and share our videos with your friends. Thank you.